Hello students, welcome to the another lecture of engineering chemistry course. In the previous class, we have completed the unit 3rd corrosion and its control. In the last class, we have discussed about the two important methods for the corrosion control. Those were the cathodic protection or electrochemical method of corrosion control and the protective coatings. In the cathodic protection, we have learned about the two methods that are sacrificial anodic protection and the impressed current cathodic protection. Then we have discussed about the various type of protective coatings, which includes metallic coatings and the organic coatings. In metallic coatings, we have discussed in detail the types of the coating, anodic coating and the cathodic coating, as well as the various type of processes used for the metallic coatings. So that's all about the previous class, what we have discussed in our previous class. So in the previous class we have completed with unit 3rd corrosion and its control. In today's class we are going to start the new unit, that is unit 4, cement, glass and lubricant. These three important topics are included in the unit 4. In the today's class we are going to start with the topic cement, and in which we will discuss in today's class history of cement, Portland cement, raw materials for Portland cement, and the important topic manufacturing of Portland cement by Rotary kiln technology. So let us begin with the introduction part. Cement. What is cement? In the most general sense of the word, cement is a binder, a substance which can sets and hardens independently and can bind other materials together. So it can be used as the binding material, and due to this nature of the cement, it can be used for the constructional purposes. So basically it is the binding material. And chemically, cement is a powdery mixture of aluminates and silicates of calcium. So what is the main components of the cement? It includes aluminates of calcium and the silicates of calcium. And since this cement has the property of setting and hardening in presence of water, so it may also be called as the hydraulic cement. The essential constituent of cement used for the constructional purpose is the aluminate and the silicates of the calcium. Okay. Now, coming towards the history of the cementing material, we know that cementing materials have played a vital role and were used widely in the ancient world. Lime and clay have been used as cementing material on constructions through many centuries. But the form of cement which is nowadays used is the Portland cement. And this Portland cement was discovered by Joseph Aspidin in 1824. Its name is derived from its similarity to Portland stone, a type of building material that was quarried on the islet of Portland in England. That is why its name is the Portland cement. So now coming towards the Portland cement. It is most widely used non-metallic material for the construction purposes. It is basically the mixture of calcium silicates and calcium aluminates with a small quantity of the gypsum. Gypsum is added as an additive to the Portland cement. As we just now discussed, that the name Portland cement is used because this powder, what is the powder? Mixture of silicates and aluminates of the calcium with gypsum. This powder mixing with water gives a hard stone-like mass which resembles with the Portland rock. That is why it is named as the Portland cement. Now, what are the raw materials of the Portland cement? Basically, the Portland cement includes two types of raw material. One is the calcareous material and second one is the argillaceous material. What are these calcareous materials? These calcareous materials are provided by the calcareous rocks, and these are the calcium carbonate containing compounds like limestone, marble, chalk, etc. While argillaceous materials are provided by the argillaceous type of rocks, which includes mainly silicate containing compounds such as clay and shell. So basically the calcareous materials are those which provides calcium carbonate, while argillaceous materials are those which provide silicate to the cement. And third component is the additive. So important raw materials are the calcareous and argillaceous, and third one is the additive, which is the gypsum. Gypsum is used as an additive to the cement. Okay, now other than these compounds, some raw materials or some ingredients are also added to the cement in a small quantity. So let us have a look of the various chemical components used in the manufacturing of the cement. First is the lime that provides calcium oxide to the cement. Percentage is 60 to 67%. Second one is the silica, SiO2, which provides 17 to 25% of the total mass. Alumina, Al2O3, 3 to 8%. Iron content, 0.5 to 6.0%. Sulfate content, 0.5 to 1.3%, and water as per the need. Here these are the symbols used when we express the chemical composition of the cement. So it C does not means the carbon. C means the calcium oxide percentage. Similarly, S does not means the sulfur. It resembles it denotes the silica oxide, and A denotes the aluminium oxide. F denotes iron oxide. S denotes SO3, and H is for the H2O. So these are the various important components, constituents for the cement. Now, manufacturing process for the Portland cement. We are going to discuss a very important manufacturing process, that is manufacturing of Portland cement by rotary kiln technology. This is the very important process for the manufacturing of the Portland cement. Basically, this process, manufacturing process, includes three major steps. First is the mixing and crushing of raw material. Second, burning. Third one is the grinding. So three main processes are mixing, burning, and grinding. The mixing process may include two types of process: dry process or wet process, either one of them. So mixing is the mixing of the various raw materials. What are the raw materials? Raw materials are calcareous material and the argillaceous material. So in the dry mixing, the raw materials limestone and clay are mixed without the addition of the water. So first, the limestone and clay are separately grinded. Crushing of the limestone rock and the clay rocks, argillaceous rocks, is done firstly. Second, all the moisture content get evaporated from the raw materials, and third one is the mixing of these two raw material, limestone powder and the clay powder, is mixed in the definite proportion and grinded in the ball mills, and homogeneous powder of both the raw material is prepared in the dry mixing. While in the wet mixing, the calcareous material and the argillaceous material, that is lime and clay, are first separately crushed. Limestone is crushed in ball mills, while the clay rocks, argillaceous materials, are first washed and then crushed in the different mills. Now both of these are mixed in the definite proportion in the ball mills and grinded together. So homogeneous mixture of both of these material is prepared with the addition of the 40% water in it. So finally the slurry of the raw material is prepared in the wet mixing, and amount of water is 35 to 40% in that slurry. So paste like structure of the raw material is prepared in the wet mixing. No, now what is the difference between the dry mixing and the wet mixing? So there are some criteria to differentiate in both these processes. If the lime rocks or the raw material rocks are hard, then we prefer the dry mixing. Okay, while if the raw material rocks are not so much hard, then wet mixing is preferred. In case of dry mixing, the fuel consumption is low, while in case of wet mixing, the fuel consumption is high, because in the wet mixing, excessive fuel is used to evaporate the moisture content later on. Since excessive fuel is and excessive time is to be utilized for the evaporation of the moisture content, that is why time of the total process is higher, while in case of dry mixing this time is lesser. But in case of wet mixing, since mixing of all the raw materials is done very properly and homogeneous mixing is completed in all aspects, therefore the quality of the cement will be higher in case of wet mixing, but the cost of production is also higher because of the higher fuel consumption in the wet process. So these are the main differences of the dry mixing and the wet mixing. Now, after mixing the raw materials, the second step is the burning. The burning process is done in the rotary kilns. Okay, this is the structure or the diagram of the rotary kiln. This part is the kiln main part, where all the heating process is done. The upper end of the kiln is connected with the exhaust chimney and inlet pipe for the raw material. So there are two openings at the upper end of the rotary kiln. First is the inlet for the raw material, and second one is the exhaust for the waste gases released during this process. So these are the upper end opening. Now basically the burning process is carried out in this part. This is the rotary kiln part. This rotary kiln consists of a long steel cylinder lined with the refractory material. This is the refractory materials, and this rotary kiln is rotating at a speed of 0.5 to 2 rotation per minute, and the kiln is slightly inclined at an angle 3 to 6 degrees centigrade. Why? Because the inclination allows the material fed in the upper end to travel slowly to the other end. The kiln is mounted on the rollers. These are the rollers. So this kiln is mounted on the roller bearings. The raw materials are fed on the upper end of the rotary kiln, and the burning fuel, this fuel is the powdered coal. The burning fuel and air are injected at the lower end. From this side, the burning of fuel is carried out. Therefore, since the burning is carried out at the lower end, that is why temperature is maximum at the lower end and minimum at the upper end. So, at the lower end, the temperature is maximum up to 1500 to 1650 degrees centigrade, while at the upper end, temperature ranges only the 250 degree centigrade. So, as per the different temperatures range, the complete area of the rotary kiln is divided into three zones. First is the evaporation zone, which is also called the drying zone. Second is the calcination zone, in which temperature range is 700 to 1200 degrees centigrade. And third is the clinkering zone, which is having the temperature 1500 to 1650 degree centigrade. Since the heating is done from the lower part, that is why highest temperature of the rotary kiln is recorded at the lower part, which is the clinkering zone. So I hope it is clear, the construction diagram to all of you. Basically, the rotary kiln, this rotary kiln is the long cylindrical tube which is lined with the refractory materials, and heating is done at the lower end of the rotary kiln. This rotary kiln is slightly inclined about 3 to 6 degree angle, and rotation of this rotary kiln is done at a speed of 0.5 to 2 rotation per minute. So this is the structural diagram. This is supported by these rollers. Upper end is connected with inlet of the raw material and exhaust through the chimney. Clear? And at the bottom part, at the lower end, there is the connection where the clinker outlet is connected. That means collection of the produced clinker is done at the bottom part. So this is the construction diagram of the rotary kiln, which is used for the manufacturing of the Portland cement. Now, I am again repeating, the burning process is carried out in the rotary kiln, while in which the raw materials are rotated at 1 to 2 ppm, 2 rpm at its longitudinal axis. The rotary kiln is made up of steel cylinder or tube having the diameter 2.5 to 3 meter and length 90 to 120 meters. The inner side of the rotary kiln is lined with the refractory bricks. Okay, and the kiln is supported on the columns of the concrete and rested on the roller bearings, and it is slightly in inclined position. Now, as we have discussed that as per the temperature ranges, there are the three zones in the rotary kiln. First is the drying zone, in which temperature is 250 to 400 degrees centigrade. What reaction taking place in this drying zone? In this drying zone, only one reaction taking place, that is evaporation of all the moisture content from the raw material. So this is done at the upper end of the rotary kiln, which is the drying zone. When the raw materials are passed into the rotary kiln, first is the evaporation zone, which is having the temperature 250 to 400 degrees centigrade. At this temperature, all the moisture contents get evaporated in the evaporation zone or the drying zone. Now all the raw materials are passed into the next zone, that is the calcination zone. In the calcination zone, what reaction taking place? In the calcination zone, the calcium carbonate decomposes into calcium oxide and the carbon dioxide gas. Okay, and the temperature range of this zone is around 1000 degrees centigrade. So what reaction taking place here? Here calcium oxide decomposes into calcium carbonate decomposes into calcium oxide and carbon dioxide. Calcium oxide is the solid. This solid now moves towards the next zone, while carbon dioxide is the gas. So gas moves towards the upward direction. So carbon dioxide moves from here and exit from the chimney, while calcium oxide along with the other raw materials moves towards the third zone, that is the clinkering zone. Now, what reactions taking place in the clinkering zone? Basically, in the clinkering zone, various type of silicates and aluminates are formed with the reaction of calcium oxide and the silica oxide. They react in different ratio, in different proportions, and forms various type of calcium silicates and the calcium aluminates, like when like dicalcium silicates Ca2SiO4, tricalcium silicate Ca3SiO5, dicalcium aluminate, that is the this is the tricalcium aluminate, tricalcium aluminate Ca3Al2O6, and tetracalcium aluminate ferrate. This. So different type of silicates and aluminates are formed in the clinkering zone at the higher temperature ranges. The mixture of all these silicates and aluminates is commonly known as the clinker. This is the small grey colored stone which is known as the clinker. So basically, what is clinker? Clinker is the small grey colored stone which includes various type of calcium silicates, calcium aluminates and calcium aluminoferrates. Now, this clinker is collected at the bottom part of the rotary kiln. These grey colored stone are now collected from here, but these are at very high temperature. So, one process is here is to be done, that is the cooling of that clinker. To cool down the clinker, we pass here the cool air. So this cool air cool down the clinker, and now these clinkers are cooled, which is now stored in small, collected through the small trolleys. So third step is the grinding of these clinker. First step is the mixing, second one is the burning, third one is the grinding. So grinding is the crushing of the grey colored stone which are formed in the rotary kiln known as the clinker. So the cooled clinkers are received from the cooling pans and sent into the mills. These clinkers are grinded finally into the powder in ball mills or the tube mills, and while grinding of these clinker, a addition of the gypsum is done. Around 2 to 3% gypsum is added to the clinker during the grinding process. What is the role of gypsum? Gypsum retarding is used as the retarding agent. What is the retarding agent? Basically, gypsum delays the setting time of the cement. That is why gypsum is added to the cement during the grinding process. We know that after the initial setting time of cement, the cement becomes stiff and the gypsum retards the dissolution of tricalcium aluminates, which we will going to discuss in our next lecture, that why it happens. So basically here we know, we must remember or we understand that what is the use of gypsum. Basically, gypsum is added to retard the initial setting time of the cement. How it retards, which will this will be discussing in our next lecture. Okay. So next part is the storage and the packaging. Finally grounded cement powder is now stored and packed into the 50 kgs bags. Okay. So now this is time for the revision. What we have discussed today we have started with the unit 4, which includes 3 topics: cement, glass and the lubricants. Today we have started with the topic cement, in which we discussed today in the detail the Portland cement, in which we have discussed two important topics: raw materials for the Portland cement and the manufacturing process. The raw materials basically includes calcareous material and the argillaceous material. Calcareous materials are those which provides calcium oxide content to the cement, while argillaceous materials are those which provide silica content to the cement. Then we have also discussed that besides these materials, one additive, that is gypsum, is also added to the Portland cement, which decreases or which retards the initial setting time of the cement. Then we have started with the manufacturing of Portland cement by rotary kiln, in which we have discussed the manufacturing process in three steps. First is the mixing, second is the burning, and third one is the grinding. Mixing is done either by the dry mixing or by the wet mixing. After mixing the raw materials, the process burning is done in the rotary kiln. The rotary kiln structure and construction diagram we have discussed in detail, in which we have discussed the, as per the temperature zones, there are the three zones in the rotary kiln: drying zone, calcination zone, and the burning zone. First is the drying zone, in which moisture is evaporated. Second, calcination zone, in which calcium carbonate decomposes into calcium oxide and carbon dioxide. And third one is the burning zone, in which various type of silicates and aluminates are formed at the lower part of the rotary kiln. This mixture is known as the clinker. Now this clinker is cooled, and then third step, that is the grinding step, is to be done. In the grinding step, clinker is grinded with the addition of the 2 to 3% gypsum in it. Finally, the grey colored powder is fine grey colored powder is packed and stored. So this is all about the Portland cement. Now this is time for the learning check. What are the chemical constituents of the clinker? Today I am leaving with the very easy question. What are the chemical constituents of the clinker? Okay. So that's all for the today's class. Thank you. Take good care of yourself and keep enjoy e-learning at home. Thank you.